Hello everyone, this is Anam Shiraz and you are joining me in the course Internet of Things with Python and Raspberry Pi. This will be a complete hands-on guide for beginner as well as intermediate users and developers of Internet of Things to build, understand and solve the real-world IoT problems. We will be building a centralized cloud platform in which multiple users can securely log in and control and monitor their authorized devices in real time. I will take this course forward in a complete reasoning-based approach, which will help you understand the why before how and what. So this course will be a complete balance between device development in Raspberry Pi and local and remote server developments using Python. The major technologies we'll be working on is Python, Raspberry Pi, Flask, AWS and Pubnub. For those of you who don't know me already, I have done my BA Honours in Electronics Engineering and then I have finished my Masters in Internet of Things from Royal Holloway University of London. Having a solid background experience in embedded system designs, software design architecture, cloud computing, and artificial intelligence. I have been mentoring some IoT startups. My major interests includes control and automation, full stack web developments for real-time applications, asynchronous programming, and wireless sensor networks. For all of my previous work and recent activities, please follow me on my YouTube channel, LinkedIn, and my GitHub account. So in the very first section, we will start off by understanding what is Internet of Things and its major components like smart devices, sensors, actuators, etc. We will also get ourselves familiarized with 4 important Internet of Things communication models. In section 2, we will get our hands dirty by jumping into development of a simple IoT project using a sensors displaying data over the web application. We will be using AJAX technique for communication between the client and the server. So this is how the web page will look like, with the black panel displaying the status of the motion detection. Our connection status is displayed on the top, which tells us that the connection is still alive with the client and the server. So after discussing the advantages and the drawbacks of the way we developed our last project in section 2, we will go ahead and study in depth about the real-time and lightweight communication protocols for Internet of Things, which are MQTT, WebSockets, and finally some hands-on demo with Pubnub. We will also study about internet security and cryptography, which involves hot topics like symmetric and asymmetric key logarithms, encryption, digital signature, and SSL/TLS, also known as HTTPS protocols. In section 4, we will reconstruct our last project to use Pubnub as a major communication protocol instead of AJAX long pooling. Here we will also learn about how to deploy IoT server into AWS cloud. Section 5 will mainly involve the development of all security terminologies that we discussed and studied in section 3. First of all, we will get our own custom domain name and then we'll secure that domain name by using Let's Encrypt certification authority. We will then implement a secure user login functionality and storing user details in integrated database. In section 6, we will implement a secure way in which users and IoT devices can safely connect with our IoT server. We will also use Pubnub Access Manager functionality for admin users to grant real-time read and write access to all the non-admin users and the devices. This is how our dashboard will look like for all admin users, where they can see list of all online users with some switch buttons in front of them to grant read and write permissions. By selecting the apply button, that specific user read and write access permissions will be changed accordingly in real time. So now that we have developed a strong, secure, real-time and yet scalable IoT ecosystem, it's time to add some more sensors and actuators and build something meaningful for the real-world use case, which will be carried out in the section 7 with a last project named Atmospheric Monitoring System, where we will also get ourselves familiarized with analog to digital converters, serial peripheral interface, and much more. And finally, this will be our final product, a dashboard displaying visual charts, displaying the data of the sensors and actuators in real time, which looks quite plausible to the eyes. By the end of this course, you will get to know what it takes to build your own one-stop IoT solution from device-level simplicity to the cloud-level infrastructure deployment complexity. You will also easily be able to take this project further by adding more devices and more functionalities according to your business needs. So to get yourself prepared for the bright and challenging IoT future ahead, I'll be looking forward to see you joining me on this exciting journey of this course. Thank you so much.